Hey everyone, it's that math magician. On this video, we're going to close out our topic of exterior angles for polygons and to start discussing the sum of those exterior angles. In the previous video, we determined how to find an exterior angle. Remember, interior and exterior angles, they add to 180 degrees. They do make a straight line. They are supplementary. So we know how to find an exterior angle. Now we want to see, can we determine what the sum of the exterior angles are? So let's jump right into that example that we were just looking at. But this time, instead of looking at how to find the exterior angle, I want to now talk about the sum of the exterior angles. So I want to revisit the first example we looked at in the previous video, and that was the equilateral triangle, the regular three-sided polygon. Remember that we determined that the interior angles all were 60 degrees because the sum was 180 degrees, and 180 divided by 3 is 60. We then learned in the last video that interior and exterior angles, they are supplementary. They form a straight line. When you extend the side out to create the exterior angles, they end up creating a supplementary relationship with the interior angles. So, to find out what our exterior angle was, we knew we had to add it to 60 to create 180 degrees. So we just took 180 minus 60 degrees. We learned that our exterior angle was 120 degrees. Whew, that was the recap from the last video. Now, I'm not interested in just one exterior angle here. I'm now interested in the sum of the exterior angles. And to do that, it's a short little extension that we have to think about, is that I know that there are 3 exterior angles there. I see them, 1, 2, and 3. I know that they are all congruent because this is a regular polygon. Regular polygons have congruent interior angles, which forces the exterior angles to also be congruent. So since I know that there are 3, and each of them are 120 degrees, to find the sum, I just have to take those 3 angles and multiply it by 120 degrees. We determine that the sum of the exterior angles for a regular triangle is 360 degrees. Very interesting that all of those all of those angles on the triangle are going to add up to the same measurement as a circle. Let's see if we can find the sum of the exterior angles for our pentagon. So if I'm looking here at the Pentagon, again, we found out in the last video that every exterior angle was 72 degrees. It was 72 degrees because each interior angle was 108. And 180 minus 108 gave us 72 degrees. But just like with the triangle, I'm not interested in just one exterior angle for this video. For this one, I want to find out what the sum of the exterior angles are. Again, for the regular pentagon, all of the exterior angles there are congruent. They're congruent because we have congruent interior angles. So since each angle there equals 72 degrees, and there are 5 of them, I just have to take 5 and multiply it by 72 degrees. Let's get our calculator out. I'll take that 72 degrees, I'll multiply it by 5, and what do you know? That angle, the sum of the exterior angles for a pentagon is also 360 degrees, just like the regular triangle. Now that is not a coincidence here, and you might be thinking maybe it's a coincidence, but it's not. I'm here to tell you that the sum of the exterior angles for any polygon is always going to equal 360 degrees. That's a fact for any polygon. You extend those sides out past the vertex, you create the exterior angles, all of them will always add up to 360 degrees. And if you don't believe me, let's go ahead then and let's look at the octagon. Let's do it one more time and determine what the sum of the exterior angles are for an octagon. Now we know, I'm not going to draw it all out for this example because I think we understand the process by now. For the octagon, I know that to find the exterior angle, I need the interior angle for this regular polygon. So remember, we're going to take the sum of the octagon's interior angles, and we know we got to divide it by the number of sides. Now, let's say you forgot what the sum of the interior angles are for an octagon. Remember, we do have a formula to find the sum, and that is 180 degrees times n minus 2, or in this case, 8. Remember, we cut the octagon up into triangles earlier, and we determined what that formula was. So I'm going to take 180 times 8 minus 2 all over 8. That's going to tell me what one interior angle is. So let's get that calculator out, and let's see if we can compute this. So 8 minus 2 is going to make 6. 6 times 180 degrees gives us 1080. But we got to divide 1080 by 8, and we see that every interior angle inside is 135 degrees. I'll go ahead and draw in one example there for you. This interior angle right there is 135 degrees. Again, every single angle inside that octagon is 135. Now, I'm going to extend this one side past the vertex so we can create that exterior angle. And for the exterior angle, we know that that angle and the interior add to 180. So all I have to do is take 180 degrees, subtract it from 135, and we'll be able to figure out what our exterior angle is. And we learned that every exterior angle is going to be 45 degrees. Alrighty, so that is one exterior angle. We want the sum of the exterior angles. There are 8 of them on the octagon, 8 sides, 8 interior angles, 8 exterior angles. So I know that to find the sum of the exterior angles, I just have to take that 45 degrees and multiply it by 8. If I do that, multiply that by 8, we see it is not a coincidence. The sum of the exterior angles is still 360 degrees. If you don't believe me now, I don't know what else is going to prove that for you. Any polygon, either it be regular or irregular, the sum of its exterior angles will always equal 360 degrees. It's that math magician, and I'll see you on the next video.